Good morning, scholars, and welcome back to another day of math learning. Let's get started. Our focus today is going to be solving word problems using line plots. Now, I want you to activate your knowledge and just kind of think to yourself, well, what do you already know about line plots, right? Now, if I were to say we are going to be solving word problems with fractions, think about how might that look, right? All right, so before starting this video, I did ask you to read the question. If you haven't done so, it's okay. Let's read it again together. It says, a group of students measured the length of their shoes. And you have that information right below, right? And so before you continue, try to name 3 different things you noticed about the information on this table, okay? At least 3. Now, if you thought along the same line that I did, you might have noticed that, well, there's different students and the length of their shoe sizes are different. There's also how many students, right? And if you counted down the list, you should have realized, well, altogether we're going to be graphing the measurement for 8 different shoe sizes for the 8 different students. And another thought I had was, I looked at my fractions, or mixed numbers, I should say, that I'm being asked to graph. And I thought to myself, well, I noticed that they have different denominators, along with there's, also a variety of whole numbers. So, like, for example, 8.5, the whole number 8 is different from the whole number 7. I also have denominators that are different. 2 is different from 4. And so that's going to kind of influence the way we create this line plot. All right, so now because of my space this morning, I don't have the criteria directly posted, but I am going to refer to the criteria that's in our presentation this morning. Okay, this is my little criteria here just to keep me on track. All right, so friends, similar to creating number lines, you're going to need a straight edge, okay? I realize that at home, all you need is something that's going to help you draw a line. I like to use a book. Now, before we get started, we're going to want to name our line plot. A line plot is similar to other organizers in the sense, like, we want to give it a title, right? And so the title of this graph will be a good title. Think about it. Okay, I'm going to label mine as the length of student shoes. Okay, let me put this down below. Next, you want to look at the data that is being given to you, because the next step is determining and creating a number plot, but we need to make sure we know what whole values or what whole numbers our line plot should be in between. And so what I mean by this is, well, if we look at the information, we know the length of shoe sizes. I have 8.5, for example, 7 3/4, 7.5, 7 3/4. And so I want to figure out what whole numbers I should create a number line. What whole numbers do these fractions, lie in between? And so if I think to myself, well, wait a minute, I feel like I should start with 7, right? Because using the whole numbers, 7 is the lesser value. And I think to myself, well, if I created a number line from 7 to 8, do you think I'm going to be able to graph that or plot that information? The answer is no, right? Because think about it. If we have 8.5, 8.5 is greater than 8. And so we need to extend this line plot to make sure that we are able to graph values anywhere from 7 to 9. Okay, so that's my first step, is creating a line where I have 2 whole numbers labeled. Okay, and I'm going to plot 7 to 9. However, also remember that my midpoint between 7 and 9 is 8. All right. Now, next. Noticing that the fractions that we are being given, or that the mixed numbers that we are being provided, they have different denominators, right? We see denominators of 2 and 4. We don't have anything here. But for the most, yep. So that's very important in understanding and creating our line plot accurately. We want to make sure that we're going to be partitioning our number line correctly. And so what I'm going to do first is I'm going to use the half benchmark, right? So I'm going to first break up every whole number into half so that I can be able to graph all my halves. I'll do this in black. Then I'm also going to need space to be able to graph fourths. And so I'm going to do this by adding an additional number of ticks to make sure that every whole number is partitioned into fourths. And so if this is half, I know this will be 1/4, this will be 1/4, this will be 1/4, and this will be 1/4. Now, I want to also make sure that I'm labeling each fraction, or that I'm labeling each tick mark, I should say. So I have 7 here, and then this becomes 7 and 1/4. This becomes 7, if I want to continue on to fourths, 2/4, right? We have 7 and 3/4. Then we have 8. What do you think this becomes? Yeah, 8 and 1/4. 8 and 2/4. 8 and 3/4. And I'm going to leave this as 9. However, notice that my 2/4 are exactly where my halves should be. And so I'm just going to rename those just so that there's no confusion. I'm going to rename these as 7.5. I'm going to rename this as 8.5. Okay? Now, the way we plot our fractions is honestly, it's just placing an X for every time we see the value being represented. And so I'm going to go down the list of students and I'm going to place an X above that number, okay? So I start in order, because I don't want to miss anything. 8.5, right? Now, if I'm looking for 8.5, remember when we initially labeled it, we said it was 8 2/4, but then I realized, 8 2/4 is equal to 1/2. And so I'm going to place an X on top of this, my line plot. Next, I'm going to do this quickly now. I have 7 3/4. I'm going to look for 7 3/4. There it is. I'm going to continue to 7.5. If we left it as fourths, we wouldn't have realized that 2/4 is equivalent to 1/2. However, here's my X mark for it, and I'm going to go down the list until I have graphed every single value. I have 8 over here, and then we're going to continue on. 8.5. 7 3/4. And lastly, 8 3/4. Okay? Now, before I like to say that I'm completely done, I just like to kind of go down the list and just make sure that I have graphed each one, right? And now if you notice, I count 1, 2, 3, 4, 5, 6, 7, 8, right? I have 8 values, and all 8 values have been graphed. And I know this is accurate because I had 8 students that needed to be graphed, or that needed to be plotted, I should say. Last but not least, the purpose of this lesson is to be able to use this information, right? And also understand how to interpret this information, right? So we're going to read 2A together. It says, who has a shoe length 1 inch longer than Dickinson? And so this is quite interesting because I need to kind of realize, well, if Dixon is here, right? And his shoe size was 7 3/4. I'm thinking to myself, well, whose shoe size is 1 whole greater than Dixon? And so it's not going to be 1/4 greater, it's going to be 1 whole number. And so think about it as if we are thinking of fourths, right? And we are at 7 3/4. It's 1/4, 2/4, 3/4, 1 whole. And so who is that friend that had a shoe size of 8 3/4? And so look at the information in the graph, and I'm going to pair it up. It was Mary. So Mary has a shoe size that is 1 whole greater or 1 inch greater than Dixon. Next, who has a shoe length 1 inch shorter than Susan? Again, I'm going to refer back to my chart. I'm going to look at Susan's shoe size, which is 8.5. And I'm going to think, well, this time I'm thinking of a length that is 1 inch shorter than Susan. And so if I have 8.5, I'm going to go backwards this time, a whole number. And so 1/4, 2/4, 3/4, 4/4, which is equivalent to 1 whole. Who is that friend that had a shoe size of 7.5? Think to yourself. Okay. And you should have realized that it was Ben. Okay. Now the reason I'm not adding this information to my answer, it's because friends don't have space. But again, that is the process. Okay.